Alrighty, so here we've got a couple of examples of how to deal with the ideal gas law as well as the idea of molar volume. Okay, so here, if you can read that, what we've got is a sample of neon gas. Okay, and we know that it's got a pressure of 1.4 atmospheres, 1.1. It's got a volume of 1.1 cubic meters, and it's at a temperature of 10 degrees Celsius. Okay, now we want to find out how many mole of neon gas is in this sample, okay? And so we're going to use the ideal gas equation to do that. Okay, first we need to convert these three units into standard units, okay? So we've got 1.4 atmosphere at the moment, so we know that the pressure is going to equal 1.4 times 101.3 kilopascals. Okay, and what that gives us is a pressure of 141.82 kilopascals, okay? So that's what we've worked out our pressure in our standard units of pascals, or here kilopascals, okay? Now, because we've already got this in kilopascals, what we're going to do is we're going to convert this 1.1 meters cubed to liters, okay? Because we know that although we're supposed to use pascals and cubic meters, if we use kilopascals, we use liters. As long as we use kilopascals and liters together, then this equation will still work out fine. Okay, so we know that this is a pretty easy conversion. 1 cubic meter is 1,000 liters. Okay, so 1.1 cubic meters is going to be 1,100 liters. Okay, lastly, 10 degrees Celsius. Okay, well we know that 0 degrees Celsius is equal to 273 Kelvin. Okay, and we know that to convert from degrees Celsius to Kelvin, we just add 273. Okay, so that means the temperature is going to be 283 Kelvin. Okay, so we've worked all that out, okay, and we've got kilopascals and liters together, so we can use these numbers without having to worry about getting the wrong answer. Okay, now we want to know how many mole of this sample we've got. Okay, so now we've got all the units, we'll plug them into the equation. We'll rearrange, so we've got N equals P V on RT, okay, and that equals 141.82 times 1100. Okay, we use the ideal gas constant, which is 8.31, as we've got up here. Okay, the temperature is 283, so just plug in the numbers into the equation. Okay, and that tells us this comes out as 66.3. Okay, so that means if we have a gas sample of neon, or of any gas in fact, that's also a very important fact, okay, that the type of gas that we're dealing with doesn't matter, okay, the size of the gas molecules doesn't matter, okay, the pressure and the volume, etc., really just depend on the number of molecules or on the number of atoms in the case of a noble gas such as neon, okay. So, at this temperature, this volume, and at this pressure, this volume, and this temperature, we know that a gas sample is going to have 66.3 mole. Okay, so here in this sample, we've got 66.3 mole of neon. Okay, now down here, we've got another example looking at the idea of molar volume. Okay, so we've got 6.1 mole of hydrogen gas at standard laboratory conditions. Okay, we want to know the volume of that gas sample. Okay, so basically all we have to do, okay, we know that we're talking about standard laboratory conditions, okay, and we know that at standard laboratory conditions, the molar volume, okay, is equal to 24.5 liters per mole. Okay, so that's the molar volume. So every mole of a gas at standard laboratory conditions is going to take up a volume of 24.5 liters, okay? So if you want to know the volume of this hydrogen gas sample of 6.1 moles, all we have to do, okay, we say V, volume of hydrogen, is equal to 6.1 times 24.5 Okay, so we've got 6.1 mole, and each one of those mole, and each one of that 6.1 mole takes up a volume of 24.5. So we multiply these figures together, we get a volume of 149.45 liters. Okay, so that's the volume of the 6.1 moles of gas at standard laboratory conditions. Okay, 149.45 liters. Okay, so I've gone through how to make sure that we've got all the right units. Okay, just converting all the units as required. Okay, and then all we have to do after that is plug them into the equation as required. Okay, and then similarly, the idea of molar volume can be used quite easily to skip past this difficulty. Okay, and if we know that standard laboratory conditions, rather than plugging in, the temperature and the pressure at these conditions, we can just use this molar volume idea to get quite easily and quite quickly to the final answer of 149.45 liters.